Today we're looking at notes L-2, radian and degree or degree and radian conversions. So you're already very familiar with measuring angles in degrees. We've looked at a circle already where this is our initial side, 0 degrees, starting here. This would be 90 degrees, straight vertical line, the y-axis, in other words, if this was centered at the origin. Where this would be 180 degrees, where from the initial side, this would be 270 degrees, and that full revolution of a circle, as you already know, is 360 degrees. Now, there is another way to measure angles, and that is in radians. Where did a radian come from? It's actually very mathematical in thought and process here. So, 1 radian came from, or is, the angle created when you take the radius and wrap it around the circle. So thus radian and radius. So what does that mean? So I've taken a piece of string here and I've measured it to be the same, as much as I could with a little bit of human error included, to be the same measurement as 1 radius. So I've cut this pink string to be the length of 1 radius of this circle. If you take this string and you wrap it around the arc here, so this arc length is 1 radius. This arc length is 1 radius. I've marked it off. The angle created here is called 1 radian. So the arc length is 1 radius, and the angle created here is 1 radian, or 1 rad. So I went all the way around the circle with my string and I marked off 2 radians, for example. I marked off 3 radians, and then starting from there, 4 radians. Of course, I did it with a little bit more care when I did it before I did the video. 5 radians. And 6 radians. So as you can see, a full revolution of a circle is a little bit more than 6 radians. Okay, and we'll talk about exactly how much more in a minute. So, and we will also get more precise or accurate measurement here in a minute, but I want you to understand that this should make sense because a full revolution in degrees is 360. If you take 360 and you divide it by 6, that would be 60 degrees. But again, this didn't make a full revolution, so it makes sense that this is about approximately 57 degrees. Not quite 60, because we didn't quite make it to the end there. Okay, so now let's kind of derive an easier way to go back and forth between degrees and radians, because we want to be able to go back and forth between the two, and with this not going around completely all the way, it kind of leaves us kind of lost with what to do when going back and forth. So let's talk about something called the unit circle. So you have another circle here on your notes page. We're going to label it the unit circle, and here's why. Okay, so we are going to center it at the origin, okay, 0, 0. This is our y-axis, obviously. This is our x-axis. Okay, we are going to say that the radius is 1 unit long. So if the radius is 1 unit long, then this coordinate here would be the coordinate 1, 0. Since this is also a radius in length, this would be the coordinate 0, 1. This would be the coordinate -1, 0, and this would be the coordinate 0, -1. So again, what we want to find here or come up with is an easier way to go back and forth between degrees and radians. So I want to find out exactly how many radians it is when I make a full revolution, right? So if I make a full revolution, how many radians is that? Right? If I go all the way around, how many radians is it? Question mark. I'm not sure, but we're about to find out. So remember that you get your radian by taking the radius and wrapping it around. And what you do know about this unit circle, this very special unit circle, is you know the circumference. The circumference of any circle is 2 pi r. Okay, so 2 pi r, where r represents the radius. Well, what's the radius of this circle? It is 1 unit. How cool. So the circumference of this circle is 2 pi. So the arc length going all the way around this circle is 2 pi. So if the circumference, or in other words, arc length all the way around this circle is 2 pi, then a full revolution is 2 pi radians, because remember, the arc length and the radian is the same. So if this is 2 pi radians, or rad, 2 pi rad, to make a full revolution, then what's half of a revolution? Well, half of a revolution then would be pi radians, or pi rad. Okay, so instead of 180 degrees, this is pi radians. So then therefore cut that in half, and from here to here, what's the radian measure? That would be pi over 2, because you cut this measurement in half. So this would be pi over 2 radians. So then therefore, if this is pi over 2 radians and this is pi radians, how many radians would this be? So if each of these is pi over 2, then this would be 2 pi over 2, and this would be 3 pi over 2. And then again, of course, we already talked about the full revolution is 2 pi radians. Now, how cool is that? So how do we go back and forth? Well, you're probably already looking at it and seeing. How you go back and forth is by using these facts, or this fact. Where's my red? There it is. So you know a couple of things. You know that pi over 2 radians, or pi over 2 rads, is equal to 90 degrees. Pi over 2 radians is equal to 90 degrees. Similarly, pi radians is equal to 180 degrees. So an easy way to go back and forth is to convert this into 1. And let me show you what I mean. So if you divide both sides of the equal sign here by 180 degrees, if I divide this by 180 degrees and divide this by 180 degrees, okay, I get pi over 180 degrees equals 1. This is so important, and what we're going to use to go back and forth between degree and radians. Let me show you. Okay, so I have some conversions on the back that you can put on your back, and let's talk. So to get from degrees to radians, so if I have 45 degrees, what's the radians? Well, let's multiply this by this, which is really equal to 1, and it'll convert. Let's watch. Okay, so if I take 45 degrees and multiply it by 1, remember, it's legal in math to multiply by 1. It's not changing the value. It's just changing the way it looks. So if I multiply this 45 degrees over 1 by pi over 180 degrees, what happens? Okay, so my degrees goes away, doesn't it? Okay, so degrees goes away, degrees goes away. So there, my unit of measure is gone. Okay, I have 45, 180. So here you would mark out 45, 180. So this goes in once, 4 times, and you get, for your final answer, you get pi over 4 radians. And that makes perfect sense, because 45 degrees is halfway in between. Pi over 4 would be halfway in between. So pi over 4 radians. Okay, let's use that formula again here. So if I have 50 degrees and I want to get to radians, I would multiply by pi over 180. Okay, so the degrees gone. Degrees over degrees gone. 50 over 180, so I can cancel out the zeros. I can divide both sides, both top and bottom, excuse me, by 10. Okay, so that would give me 5 pi over 18. All right, so then looking at negative 225, it's still going to work the same way. You're still going to multiply by pi over 180 degrees. Okay, of course my degrees are going to go away. All right, 225 and 180. Here this would simplify to 5. Here this would simplify to 4. Okay, and so you would have negative 5 pi over 4. And that would be your final answer. So on this side here, when you're going from degrees to radians, your answer should look like typically fractions with pi. Okay, your answer should have a pi in it. Okay, and typically fractions, not 100% of the time, but typically. Going the other way, radians to degrees, so let's talk. Okay, going from radians to degrees, we're going to think of this in another way. So pi equals 180 degrees. We already agree with that. But in this case, let's divide both sides by pi. Okay, if I divide both sides by pi on the right here, I would have 180 degrees over pi equals on the left 1. This conversion is going to help us when going back and forth from radians to degrees. Okay, so if I take negative 5 pi over 12 and I multiply it by 1, or in other words 180 degrees over pi, what's going to happen? Well, my degree symbol is going to stay, but my pi's are going to simplify out, right? And then here, you're going to simplify 180 to 12. 12 goes into 180 15 times, and 12 goes into 12 one time. So here you would have negative 75, 1 times 1 on the bottom, so you've got nothing in the denominator, and your degree symbol is still there, so negative 75 degrees. Okay, similar here, we're going to multiply by 180 degrees over pi. Okay, so in this case, our pi's simplify out. All right, there's no other simplification that can be done. So you're going to have 900 degrees over 7. Now, when you're doing degrees, you always want whole numbers or decimals, not fractions. So you're going to approximate this at, when you put it in the calculator, I don't have one in front of me, but it does become 128.571. Remember, we're rounding to the thousandths all year long. 128.571 degrees. That's our final answer. Last one, 6. If you have 1.6 radians and you want to convert it to degrees, you're going to have to multiply by 180 degrees over pi. And that's going to be 288 degrees. Nothing simplifies out here, divided by pi. And again, fractions is not something that you want when talking about degrees. So you're going to put that in the calculator, and when you round to the nearest thousandths, you'd get 91.673 degrees. And then again, on this part, make a little note to yourself like you did above. Remember, above it was fractions with pi. For degrees, you want whole numbers or decimals only. No pi.